Hey, this is Corey Glenn. I'm going to show in this video how to make a simple framework to put inside of a maxillary overdenture. There's a lot of applications for this technique. You can make partial frameworks if it's not too complicated of a design. You can make bars to go inside of a hybrid. There's many cool things that you can do for this. But for this example, I'm just going to be showing making a simple framework. So this is a case in which we're designing some digital dentures. I've scanned in the upper and the lower model as well as them occluded in the bite rims, but really only the maxilla is where I want to create the framework. So what I'm going to do is just get my model oriented where I'm looking at it from the occlusal view, use the select tool, and I'm going to come in here with a fairly small spot size, maybe actually just up from that slightly. That looks appropriate. And so what I will do is first of all outline the lingual extent or the palatal extent of this frame, and this is going to come across. I don't want to go too far into the palate should they ever decide that they need to remove the palate from this framework. I'll extend this up and onto the ridge, and as I'm doing the part on the top of the ridge, I don't want to engage this in any undercuts, so I'm just going to go more or less to the top of the ridge and then come back down. Something like this. And then we can do an anterior portion to it as well. So this is what the outline of the framework is going to look like, and now I can smooth out the boundaries on this. So go first of all optimize boundary, modify smooth boundary, and you'll see that this turns into a much smoother outline to this. Accept that, and now go to edit and offset. So how far off the tissue do you want this framework to sit? In my case, I would like to have 1 millimeter of space for acrylic to be underneath this framework, so I'm going to offset it by 1 millimeter, and you can see that right here. Let's accept that. Here is my framework offset. Clear the selection, and now this is still part of my maxillary STL. You can see that as I've got this selected, it's still all of these surfaces showing. So I need to separate this into its own STL. So I'm going to select it all again, edit, and separate. Now it is its own STL. I could change this, and let's call it frame in our objects browser. And now we have this shell that is sitting 1 millimeter off of the tissue, but there's no three-dimensional shape to this right now. It is just a shell. So now we need to go ahead and create some three-dimensional shape to it. Once again, double click on the surface, select it, and this time come up to edit, and we're going to extrude this shape. How thick do you want the framework to be? In this case, I also want the frame thickness to be 1 millimeter. So it's 1 millimeter off the tissue and 1 millimeter of thickness uniformly throughout. And that could be whatever you want it to be. Again, make it 1/2, 2 millimeters, whatever. So now you can see this actually has some three-dimensional shape to it, and I can accept this. And if it was necessary, if you feel like there's some sharp edges, you can come over to your Sculpt tools, use your brushes. Robust Smooth is probably the best one to use, and I'm going to hide for a moment the maxillary model, and let's just hit some of these spikes that are on this where there's rough spots in the framework. Any little pointy edges like that can be taken care of. Smooth those down. And that's looking pretty good. I don't see any other really rough spots on this. This is going to be embedded within the acrylic, so I'm not terribly concerned about how pretty it is. I just want to make sure that it's an object that's not got folds or anything like that in the mesh that would make it hard to fabricate. So now we have this object, and the only problem with it is that if you were to try and process this, imagine dropping this onto the model, there's nothing to keep it up that 1 millimeter off the tissue. So you need to create some tissue stops. And the way I'm going to do that is clicking the magnet beside the upper model and then looking at this from the what would be the underside of that framework, and I'm going to now select the frame in the objects browser, go to Sculpt, use your brushes, and use this attract tool. We're going to use the attract tool and now just pull off some tissue stops right there. Do you see how the mesh just changed a little bit? That means it just came into contact with this model which I have magnetized. Come over here and let's do the other side of the tripod. Use your attract tool. Right there it just ran into the model, and now I have that portion and I just need an anterior stop to the tripod. We'll go up here to maybe the region of the incised papilla and just repeat the process. So now we have 3 tissue stops on this model, and I can turn off the attract tool and look at this now, and you can see these 3 tissue stops. So everywhere except for right here, here, and here, there's going to be 1 millimeter of space between this framework. So if I'm processing this on a conventional stone model, now it's going to be possible to drop this on and it will stay oriented up and off the tissue so that acrylic can flow up under this and create the denture with the framework fully embedded with the exception of the tissue stops, just like you would do in a partial denture. So this is it. Really at this point it's ready to export. You might just run the analysis tool on it first. Inspector. The inspector will tell you if there's any holes or problems in the mesh. If there were, auto repair all. And this is ready now to export. So export, you could save this as, let's say, the denture frame. Save that and now upload this to wherever you want to have this printed. You've got the option of printing this in 3D castable resin. So let's say you've just got an affordable desktop printer, you can print this in castable and then have it cast by your local lab. Alternatively, you could have this uploaded to a lab that can directly print in metal, which is what I'm going to do. I'm actually using Bertram Dental Lab, and a framework of this size is roughly $135 or so to have printed in chrome cobalt, which will be incredibly dense, incredibly accurate, no warpage, nothing like that. So you can imagine this same technique can be used to make implant bars, hybrid frameworks. There's many different applications for this, so hopefully you'll find that useful, and happy denture making.